Yes.
Yeah. Are we live?
Yeah, you are live. Start.
Oh,
Okay, so
right. Good morning, one and all present here. On behalf of the Technology Committee, I would like to extend a warm introduction to all the participants who are present here.
Hello,
hello,
Ansh.
hello Ansh.
Okay, I think he's stuck. Wait.
Mm.
Okay. Hello, participants. Good morning to one and all present here. So, on behalf of the Technology Committee at the World Youth Art Federation, I would like to extend a warm and hearty welcome to all the participants of the workshop who are present here for the workshop Introduction to Machine Learning and Deep Learning. So, by the end of this 2 hours long workshop, we hope that we would have an enriched knowledge regarding the existing upcoming fields like artificial intelligence, computer vision, deep learning, and the various applications and challenges related to them. Right. So, today we have with us Professor Murdang Pandya, who is working as an assistant professor in the IT department at Charusat University, while also pursuing a PhD from there. He is having 8 years of experience in teaching. His research interests include data and web mining, machine learning, soft computing, deep learning, and other applications. He is a certified instructor and ambassador of NVIDIA Deep Learning Institute and is also serving as a reviewer of many international journals. So, keeping this in mind, he is also a member of a team at League India AI, which is a startup governed by Government of India in the field of AI, which is operated from Bennett University. Yes, conducted innumerable workshops, seminars, and training modules in the field of artificial intelligence and machine learning all over the country. And he has also guided over 100 UG and PG level projects. We are truly grateful to have you, sir. So, one last thing before I hand over the session to Professor Murdang, in case all the participants have any queries or any questions, you can just write them in the chat box, and Professor will answer these questions accordingly in the meantime. All right. So,
Okay,
sir, over to you now.
okay. Thank you so much for a warm introduction. Okay, so let me start my session. Mm, so, as you know, our 2 hours workshop is based on that introduction about ML and DL, right? So, before starting ML and DL, you must know this term AI, right? Artificial intelligence, right? So, basically, artificial intelligence is a superset you can consider, right? Uh, and ML and DL are the subset of that particular thing, right? So, uh, if you think about artificial intelligence, right? So, how you can define this particular word, artificial intelligence? Basically, artificial means you can consider as a non-natural thing. That you consider as a artificial, right? Non-natural one. How you all already know that we are having a intelligence in us, right? So how we can show our intelligence, right? What are the bases? So I have defined that intelligence in three terms, right? So intelligence is basically ability to understand, think, and learn, right? So that is you can define as an intelligence, right? Three things: ability to understand, ability to learn, and ability to think, right? So this is how you can define artificial intelligence, right? So artificial is non-natural thing. So our goal is, or basically artificial intelligence goal is to make a non-natural thing that can learn, that can understand, and that can think, right? So this is the basic goal of artificial intelligence. And though the ML and DL, machine learning and DL, machine learning and deep learning is a part of artificial intelligence, ultimately the goal of machine learning is machine learning and deep learning are same, right? So artificial intelligence, you can say as a superset. The subset of that artificial intelligence, one of the subset is machine learning, and machine learning's one of the subset is you can consider as a deep learning. And deep learning nowadays uh, 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 is into the market right now, right? This is the basic introductory section that you want that you have to understand before starting our session, right? So AI, that means artificial intelligence, the goal of AI is what? Basically, to make a non-natural thing, right? So to do this three tasks, we have this all terminologies: machine learning and deep learning part, right? So today we are going to see that thing, right? So let me start the session. Yeah. First of all, this is our outline of today's session. That is, first of all, we will understand the First of all, we will understand the artificial intelligence definitions. Then we will move towards the machine learning and some of the application of natural language processing, computer vision, and its challenges. After that, to solve that particular challenges, and we have a deep learning section. So, deep learning, or what is deep learning? Why deep learning? Introduction of that particular thing, and we will see some deep learning timeline also, right? Okay, so yeah, this is all about uh, our today's outline. Okay, and this is nothing but uh, just a discriminator. I am just you I if I have used some of the proprietary images into this particular thing, I just want to apologize that particular thing. And this particular video is for learning purpose, so I am just notifying that particular thing before starting my session. Okay, let's do it. Okay. Right? But when you write that what is artificial intelligence in a Google, you will find lots of definition. And same thing I have done here. I have written what is artificial intelligence, and I have found number of definitions. Right? So and I have just listed that particular definition. But uh, amongst that all, uh, I like the most is indicated in this green letters. Right. Let me just give you a brief understanding of this all definition. Then I will move towards the that green one. Right. So yeah, first of all, AI is branch of computer science. Right. Basically, to solve a problem of computer science, there is an innovation of AI, and AI having a some problem domain. To solve that particular problem domain, we have lots of options like ML and DL kind of thing, right? So artificial intelligence is the science of making machine to do things that would require intelligence if done by men, right? So that is the basic criteria of artificial intelligence thing. So we have to make such a machine that required intelligence, right? Or that have intelligence. The same task if that man or people want to do, so people have to apply their intelligence to perform or solve that particular task. Same thing we want to incorporate into the machine. So that is the basic criteria of artificial intelligence. All right. Another thing, that is a existing a new effort to make a computers think, right? This definition you can find from regarding artificial intelligence, right? So artificial intelligence is not a machine or system. First of all, that is a pure myth, right? It's a one kind of study. It's a one kind of study in which the task that you have to perform is to get human like intelligence into the machine, right? So how you can make machine intelligence like human, that's ultimately a artificial intelligence. That's a study, right? Whole research area, right? And to implement that particular AI, you can develop such a system that will produce that AI terminologies or AI goals, right? So that artificial intelligence is not a system. First of all, it is a study of the computation that make it possible to perceive, reason, and act, right? This is given by one of the researcher called Whitson. Okay, now I'm on to my favorite one, right? And you can understand this artificial intelligence term very easily. So basically, AI, that is this definition is suggested by Rich and Knight, right? So this artificial intelligence is a study of how to make computers do things which at present human can do better, right? So artificial intelligence is one kind of study. It's a one kind of study to make computers do the things at present human can do better, right? So that's the scope of AI basically, right? So once we have such a intelligence, once we have such a intelligence like into the machine, so that's the ultimate goal. Computers do things which at present human can do better, right? So the basic goal is to make a machine that will do the things like human like intelligence, right? So that's the definition of AI I like the most, right? Now the statement that I have written at the end of the PPT is basically it is like it looks like very funny because artificial intelligence, that term coined into a 1956 by John McCarthy at MIT, right? And in 2020, right now I am giving you an introductory session on AI and ML and DL, right? So that is this is basically uh, what you can say. You can consider as a funny thing, but why actually I am doing this particular thing right now? because of because of the term deep learning, right? That is very new. And this deep learning part is nowadays into the market because of data availability, right? In 1956 there is a very lots of shortage of data, but right now if we consider about the data availability, we are generating a lots and lots of data per second. Right now I am delivering a lecture, that is ultimately we are generating a data for someone, right? YouTube getting some information, Zoom getting some information, because of data availability. Right now, introduce that deep learning part into this. I want to introduce that deep learning part into this session, right? uh, by taking this particular knowledge, let me move further. uh, so uh, yeah so now we will understand the AI term in terms of human, right? So as you know, the AI strategy is what, or AI goal is what, basically we want to incorporate all the functionality available in us, or all the intelligence available in us, we want to incorporate into the machine. That is the goal of AI, right? So first of all, we will see our intelligence thing, and to incorporate that our intelligence part into the machine, which field AI having, right? So in this way we will generate a AI tree first of all, right? So AI tree. So in this particular slide, at the end of slide, you will know which are the different fields available into the AI to incorporate that understanding, thinking, and learning part into the machine, right? So this PPT will introduce you that particular thing, right? So as you know, artificial intelligence is a part of computer science, right? So you can define like this: computer science and AI, right? Now we will understand that AI terminology, or AI different fields in terms of human. So let's design a human one, but I have tried to make that particular thing. Uh, okay. So let's consider this is the picture of human, which is having a two eyes, one nose and mouth, and two ears, and one small hand kind of thing, and two small legs, right? So that is a picture of human, right? So one by one we will reveal. We already know, but in this particular PPT, one by one we will reveal our intelligence, right? So in terms of uh, our intelligence, let me start with one thing, that is the human, or human can hear and speak, right? So that is the intelligence part, right? On a machine cannot do that particular thing directly, right? So human have that ability, that can use that their intelligence through speaking and listening part, right? So speaking and listening is a capability of human, in which human are using their intelligence also, right, to communicate with each other, right? Human, yeah, right. So that speaking and listening ability, right? So that you can consider as a intelligence in us, right? So we are using some speaking skills and listening skills to solve some of the real time problems, right? Like communication problem, right? So same thing, if you want to incorporate into the machine, so that particular field you can call as a speech recognition. So that field in AI, AI field, and you want to incorporate listening and speaking skills into the machine. So you have to work on this speech recognition thing or speech recognition part, right? And basically this speech recognition thing is based on statistical learning, right? So initially it is a part of statistical learning, right? So based on statistical learning we will incorporate that speech recognition into the machine, right? Okay, one let's take one more ability of human, that is this one, right? So human can read and write, right? That is one more ability of human, right? So same thing, if you want to incorporate into the machine, so that particular field you can know, you can say that particular field is natural language processing, NLP, right? Natural language processing, right? So now second ability, a reading and writing skills of human, right? So it is very difficult to write some letters by machine, right? So if you want to make such a machine that can write uh, like human, and read like human, right? So that particular field known as a natural language processing, NLP, right? So that comes under the AI part, right? So artificial intelligence having a such a field called NLP, ability to that will give it, right? So speech recognition, natural language processing, basically based on statistical learning, right? So this is a second ability. Let me move towards the third ability, right? That is a understanding of surrounding environment, right? Understanding the surrounding environment. Human can pick some object and take it into one place to another place according to the shape, weight, and design of that particular object. When we see a stairs kind of thing, so we can climb that particular thing, right? If we have a chair kind of thing, so we have that much intelligence, so this particular table design is for sitting purpose, right? So we are understanding based on the usage of that particular thing, right? So AI wants that same thing with the machine also, the robotic part, right? So if you want to design a robot, so first of all you required a ability to understand the surrounding environment, right? So that thing that you want to incorporate into the machine or robot kind of thing, right? So that will understand the surrounding environment and do the task based on understanding the surrounding environment, right? So that particular field you can consider in AI is robotics, right? So you that AI area is making such a robot that can understand, analyze the surrounding environment and work accordingly, right? So that field so we are just making such a robot that that can jump a wall, that kind of thing. When that robot is seeing something like a chair thing, chair kind of thing, so that robot can understand this particular design is for sitting purpose, so robot can sit onto that particular chair object, right? Okay. So this particular field, as you know, as I have conveyed to you, that field is known as a robotics, right? Now this is the third ability. Now let me reveal a fourth ability of human, or before that, this robotics. Before machine learning and deep learning trend, we have that robotics kind of thing in AI, right? So that thing, that robot training, we are doing through symbolic learning, through symbolic learning. So we are producing some chat symbol, stat symbol, some object symbol to the machine, and through symbolic learning, we will train our robot, or we would be training our robots, right? So so robotics we can implement through symbolic learning, and there is one more way, right, that we will see later, right? So the basic initial stage robotics are based on symbolic learning, right? So how that particular robot is understand the object, so that training is based on some symbolic way or symbolic learning. Now so human can, right, so that is most important capability of human, right? So we can see our surrounding environment, right? We can see each and every object surrounding us, right? So and with our eyes we can see everything, right? So apart from seeing, we will also that particular seeing part, if you want to incorporate, right, into the robot kind of thing, right, into the machine, right? So if you want to incorporate that vision capability into the machine, that field you can call as a computer vision in AI. Computer vision, right? So in this computer vision, we are incorporating a vision capability of human, vision capability of human, right? Apart from that vision capability, human can process image also, like this. With our eyes we can see the lots of images or lots of objects surrounding with us, but if we want to focus on some of the object, so accordingly we can process the thing, and we can generate a such a image of the object that we want to focus, such an image of the object that we want to focus. As an example, we want to ignore this particular uh, uh, peoples available onto the road. So accordingly, we are processing the processing the vision, right? So by default, we are doing some image processing part through to execute that computer vision thing. Most important part to achieve a computer vision thing, right? So we want to process the image. After processing, we can have a ability to classify something, detect something, or segment something, right? These are the three important things: segmentation, classification, and detection, right? That we will do through our eyes, right? So that thing, if you want to incorporate into the field of computer vision, right? So you require some techniques of image processing. So image processing is not related to AI, but to execute computer vision part, we required a image processing thing, right? So that's the scenario. That's why here I have incorporated image processing. Not even computer vision, but in terms of robotics, you required some image processing also, right? So image processing you require, right? Image processing is not an artificial thing, artificial intelligence part, but to execute this two phenomena, robotics and computer vision into the AI, we required some help of image processing, right? Because we are doing some image processing here, right? Like this. Okay. So the next thing, the capability of human that can recognize the patterns available into the picture, right? So if you see this particular thing, if you see this picture, right? So in this, as a human, what we can basically, if I see picture, so I can see the, right? So as a human, I can recognize different patterns available into the picture or available into the scenario, right? So same thing, if we want to incorporate into the machine, we are having a pattern recognition field. Pattern recognition field. So now through pattern recognition, machine can able to see different patterns available into the scenario or picture, like this picture, this, which is having a different crosses and circle, two different design, right? So machine is so in pattern recognition, we have to train our machine such a way that that can see the patterns available into the picture or video, you can say, right? So to incorporate this pattern recognition part, we required a lots of data. When you pass this number of squares and circle data in a large scale, right? So machine have lots of observation kind of thing. Machine can see different patterns of crosses and different patterns of circle shapes, right? So by providing a data to the machine, we can learn a machine such a way that that can understand from the data and reveal interesting patterns available into the data, right? So that is the task of that pattern recognition part in AI. If we provide a data to the machine, machine can read the data that will be useful to find out the patterns available into the data, different novel patterns available into the data, right? To achieve this pattern recognition, nowadays we required such a method that can be a data driven, not a symbolic one, but data driven technique. Before that, we will have one more technique, that is symbolic learning. We will pass a some symbol, and robot and machines can have a vision capability and understanding the surrounding environment capability. But same thing, if you want to incorporate into the machine, you require a data. You will give data to the machine will read data, understand data, and able to infer something from the data, like number of patterns, right? So it is based on totally a human tendency, right? How we will learn, basically, from the childhood to the younger age. Whatever we are seeing, whatever we are observing, whatever we are experiencing, that is our data actually. and based on that experience, observations, we are making such an assumption or such an inference that will be useful in our day-to-day life to make such a useful decisions, right? So same thing if we want to incorporate into the machine, so we required is lots of experience. Lots that machine require lots of experience, lots of observation, right? So that observation experience itself will provide a data to the machine artificial intelligence or machine learning algorithms, right? So that this pattern recognition part, if you want to incorporate into the machine, there is a one more field of called as a machine learning. So machine learning is a data driven technique. So instead of symbolic learning, we will give a data, actual data to the machine, like this picture, right? Actual picture having a different pattern, or some Instagram data, some blog data, right? Some YouTube chat data, right? Then WhatsApp data, WhatsApp chat data, right? So that data we are going to provide to the machine, and machine learning algorithms will take that data, understand data, and try to learn something from that data like us, right? So that machine learning is totally based on data driven technique, right? So that's why I am giving this introductory lecture, right? So nowadays, as we have a lots of data availability, right? So if we provide more and more data to the machine will incorporate more and more information from the data. And if machine takes more information, it will generate a more useful patterns from the data, or more useful decisions from the data, right? So the more data you are giving to the machine will learn more, right? So that's why this machine uh, into the market. The left hand side part, this is the brain design, right? So left hand side part is like our nerve system, all right, brain system, right? So as a human, how we are learning, basically we are seeing, we are observing, we are experiencing something, and that data saved into the our brain will process something based on the previous experience. uh, we are uh, we are performing our current task, or we are ready for our future task also, right? So in AI field, there is a thought in AI field. Can we mimic? Can we mimic the function and structure of human brain artificially, and that structure and function will work like human, and can we have that cognitive capability or not, right? So that is a main field, right? So that artificial intelligence having a such a thought that all the learning we are performing is based on our brain. So our brain is doing each and everything, the intelligence part, every action we are performing, the reason behind it is our brain itself, right? So can we mimic the brain, so we so that machine can also work like human, right? So that is the ultimate goal of AI actually, right? So AI wants such a machine that can work like human, right? So we are working with our brain. Can make a such a system to incorporate that structuring of and functioning of brain into the artificial intelligence part. There is a field called artificial neural network, ANN. That field you can call as a artificial neural network, right? So we are generating a artificial network, artificial network. We will see the design of that particular artificial neural network. So that network having a lots of connections, right? Like in our brain there is a lots of parallel neuron connections, right? So same way we in artificial intelligence, the researcher and artificial study, AI study, has try to make such a neurons that will connected with each other and try to learn something from that, right? So that field, the brain related thing, the understanding and learning capability, right? Of brain, if you want to incorporate into the machine in AI, you have one option called artificial neural network, right? So artificial neural network is work like human brain, but very a small scale, right? Because in our brain there are lots of neuron connection. We cannot able to implement that much of neuron into that much of neuron artificially, right? But we can mimic a small section of a brain working, right, through artificial neural network, right? Okay, now let me come to a current topic, that is deep learning. So artificial intelligence, sorry, are trying to, you are increasing the neurons into the brain, or you are increasing the number of neuron into the artificial neural network structure. So actually you are increasing the complexity of neuron. So if you are increasing the complexity of neurons into the artificial intelligence, that will give a automatic learning capability, automatic feature selection capability to the model, artificial neural network model, right? And that field you can now call as a deep learning, right? So it is under the data driven technique, machine learning. And machine learning having a one more technique called artificial neural network. And artificial neural network, if you increase the complexity of artificial neural network, you are into the deep learning field. And deep learning will give you a automatic feature learning capability from the data. You will pass a raw images of cat and dog, raw images of horse, right? You will give to the deep learning algorithm. That algorithm itself identify the different features available into the different pictures. And ultimately when you test that particular thing, when you give a new image of cat, deep learning algorithm will give you that classification. Okay, this particular image is of cat, or this particular image of dog. This so learn features by themselves. But in machine learning that is not the case. We will see that difference also in future slides, right? Okay, so now we have introduced that deep learning thing. Now, as I told you that there is one more way to vision that particular thing. All right. So yes. So to incorporate computer vision through deep learning, to incorporate computer vision through deep learning, whatever image we have pre-processed for our vision objective, that particular pre-processed object, if you want to give to the machine, right, and to understand that particular thing, what we can actually achieve, the object detection, segmentation, and classification part, right, through this particular thing, right, this pre-processed image. So we can detect that there is a tree, there is a sun, there is a road, there is some people, there is a car kind of thing, right? So these are the object detection thing, right? So ultimately, we that machine has to process that particular image such a way that we can have a object recognition, object detection, classification, right, pattern recognition thing, right? So when we give that particular pre-processed image, and machine will see and take that particular image as an input, and bottom to right, that will take that pre-processed image and take the pixel information from the image, and move left to right and top to bottom, and ultimately achieve the features available into that image. And finally, we will have a understanding of object recognition, and object detection part, right? So that particular uh, algorithm uh, that will read image left to right, top to bottom, that algorithm we have, that that is called as a convolution neural network, CNN. So deep learning, through deep learning, we can perform a computer vision part with the use of CNN algorithm, convolution neural network, CNN algorithm, right? So finally, through CNN, we can scan that particular image left to right, top to bottom, and ultimately we are achieving a computer vision section that previously we are achieving with the symbolic learning part. But now there is a second way. Because of data availability, computer can take data and learn from the data. We are having a uh, uh, one more field called machine learning. Machine learning having a one subfield, that is a complex artificial neural network, deep learning part. And deep learning has such an approach that can take that picture and scan left to right, top to bottom, and take a some analysis we can achieve a computer vision thing, and through machine learning, right, with the help of CNN algorithm, right? And ultimately, after achieving that computer vision, we will achieve basically object recognition. Of course, the main goal is ultimately we are identifying the object recognition: tree, sun, road, car, children, people, right? So, so actually, we are achieving a computer through this deep learning CNN algorithm, we are performing a object recognition task, right? So that required for a machine to incorporate this facility of vision of human, right? To incorporate vision capability, we required a CNN algorithm or CNN process, and by which we can achieve a computer vision, and finally we will achieve a object recognition part, right? So this is all about a vision area. Now one more capability of human, that is remembrance part. I think we all know what we have had dinner last night, right? So our brain has that much capability to remember something, right? So that remembrance capability, if you incorporate into the machine, what you can do? So through deep learning we can achieve with the use of one structure or architecture or algorithm, whatever you can say, that that part called as a recurrent neural network. That architecture, recurrent neural network. So that will help. That will help machine to remember the nearest past. Nearest past. Right? So remembrance capability, if you want recurrent RNN, recurrent neural network, right? Okay. So this is we can say that the tree of artificial intelligence, right? So artificial intelligence we can achieve through symbolic learning and machine learning. Machine learning is a data-driven technique. The more data you will give to the machine will take that data, understand that data, and we can achieve some intelligence capability like speaking, listening, reading, writing, vision, pattern recognition, remembrance capability, object detection, object recognition, right? This all capability we can achieve artificially. That is the goal of AI actually, right? So this is the AI tree you can consider, right? And mainly the problems that you want to solve in real life, that is what? That is related to classification, detection, and prediction part. Classification, detection, and prediction, right? So detection in terms of whatever we are seeing through our eyes, we are actually recognizing the object recognition thing. That is one problem, right? That we want to solve artificial. Second thing is the classification between two objects. Like we can easily say that this is cat and this is dog, right? But it is very to hard to understand by computer itself, right? So how computer can classify objects, right? And one more thing, that is prediction part. Prediction. So as a human, we have that much capability, so we can predict some nearer future or based on some previous experience. We have such a tendency that uh, we can predict the future kind of thing. Prediction part. Like if we observe our surrounding environment, if we see there are black clouds in the sky, right? So we can predict that particular thing. So there will be rain within 1 or 2 hours. So that's a prediction, right? So same thing. If we want to incorporate into the machine, so machine require lots of data, right? And based on the data, like human, machine can also predict something like weather forecasting thing, right? Stock market forecasting, right? So these are the prediction, right? So this particular three domain, three problems we can solve through different machine learning categories, right? Different machine learning category. Now we are focusing on data driven technique only, because nowadays we are having a lots of data. Even medical field nowadays we are getting lots and lots of data, right? Uh, right. So we can use there's this data driven technique, right? For the classification of cancer. It can be a breast cancer, lung cancer classification, yeah, any disease classification, right? Diabetic retinopathy, that this all kind of problem is to data driven engineering and deep learning. Machine learning is having a different fields or category, what you can say, category that basically the machine learning has divided uh, into three different categories based on the data availability: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning, unsupervised learning, and reinforcement learning, right? So first of all, let me introduce supervised learning. So supervised learning is basically uh, we are providing a data to the machine with some label, with some label that is comes under the category of supervised learning, right? So we are giving a cat image with cat label, we are giving a dog image with dog label, we are giving a horse image with horse label, right? So actually we are giving a cat image and saying that to the machine, this is a image of cat actually, right? So we are collecting a data such a way that we are having a image also, and we are having a, some label also that indicates to the computer that this is the image of cat. Now that cat image goes into the computer, machine learning algorithm will scan that particular image, identify the features of cat, of dog, and of horse, and ultimately generate a three different feature maps, three different feature maps by taking the features of cat image, dog image, and horse image, feature map, feature related to cat. That for the feature we required a lots and lots of image of cat, lots and lots of image of dog, and lots of image of horse. The more images we are providing, machine will take more information from the image and try to generate a more accurate features of cat, and that feature will useful for the classification purpose, right? How? Now we have provided lots of image of cat with label, lots of images of dog with label, lots of images of horse with label, right? Through the machine learning algorithm, machine has fetched number of features like uh, the ear structure, eye structure, nose structure, lip structure, body structure, leg structure, right? Of the objects, right? So ultimately, machine has incorporated lots of features, right? So when cat is there, cat is having a this kind of nose structure, ear structure, hair structure, body structure, leg structure. When there is a dog, so dog having a different feature map of eyes, nose, ear, hair structure, body structure. Again, same way, horse having a different structure, right? Now machine is ready with three different feature maps. Now the task is to identify a new image. Identify a new image. So what is, we are doing some testing kind of thing, right? So we are giving a new image cat. New image of, and it will go, and for testing purpose we are not giving that label that this is cat, because we want computer to put that particular label, right? So we are giving a new image without label, new cat image. It goes to the machine learning algorithm. It goes to the machine learning algorithm, and it will take all the features. Now new, that machine having a new image feature, and machine is already trained on three different features: cat, dog, and horse. Now there is a new feature and old features. So this new feature compared with three different features, and the maximum feature matches with the particular category. So right now we are having a cat, so it will obviously match with the cat feature. So machine will ultimately classify this new cat image as a cat. If we pass dog, so it will classify dog. If we pass horse, it will classify horse, right? So this is the task. This is the classification. So you want to perform a classification task, you require a lots of data with label, right? So you have to gather lots of cat image, and you have to make this title as a cat, make that particular dog as a dog image as a dog title, horse image as a dog horse title. Give all the image to the machine learning algorithm. Machine learning algorithm will fetch that feature as well as label. Accordingly, it will learn, it will train, and ultimately produce a feature map. And now onwards, we can test our different images, right? New images. Yes. Okay. So data with that particular method you can call as a supervised learning. Data with label, right? It is just like you are giving an exam and under the supervision. You are giving an exam under the supervision, right? So same thing, supervised learning, right? We are giving a data, but we are giving also a reference. Okay, this particular data is this to the machine. So machine can learn something and take consideration of that label also, right? So that is a supervised learning part. Second technique, that is a unsupervised learning. So what if we have cat, dog, and horse image, but we don't have a label for that? We don't know what are the pictures of cat, what are the pictures of dog, and what are the pictures of horse, right? So at that time, we have lots of images. We have lots of images, but we don't have a label on that. And our goal is to identify the cat, dog images, and horse images, right? So how we can identify? So for that, we are having the unsupervised learning technique. So in which we are giving a data to the machine without label, and machine will automatically extract the features, collect the features from the image, same way like supervised learning, but without label. Automatically extract the feature and ultimately make, instead of three feature map, ultimately that unsupervised learning will make it three different clusters of features. So cat having a this feature structure, that will make a similar of an object. So that clustering task, when we give a XYZ image, so machine will tell that this is machine have knowledge of all the features and characteristics of image. But right now machine don't know about the label of that particular thing. But through unsupervised learning, we can learn the feature and ultimately we can set a object in a different cluster. So when you give new image, that new image goes into cluster 1 if that particular image is of cat. If we give a cat dog image, it will goes into a cluster 2, but it will not reveal this is a dog image, right? But it compares with all the feature and characteristics, and it will put accordingly into the cluster 1, cluster 2, and cluster 3, right? So it is like we are having some task to identify mm, a weak student, medium student, and strong student, right? So weak student having such a functionality or characteristics, medium student having such a functionality and characteristics, and strong student have a such a functionality and characteristics, right? So machine will take all the data, ultimately learn something, each and every functionality and characteristics, and when you give a new characteristics, it will automatically put that particular new list of characteristics and functionality into one of the clusters, right? So that is a clustering plan. So that you can achieve through unsupervised, right? So classification is you can perform through clustering, you can perform through unsupervised, right? That you can perform through supervised learning. And the last thing is reinforcement learning. Reinforcement learning is what basically you don't have a of course you don't have label, and you have just a initial stage. You have just an initial stage and goal stage. If you have such kind of data, like you want to go to Ahmedabad to Baroda, but you don't know the path, how to reach that Ahmedabad to Baroda, right? So in this particular case, what you have, your initial stage, that is Ahmedabad, and your goal stage, that is Baroda, right? Now your task is to reach Ahmedabad to Baroda as optimal path by selecting a optimal path. Right? So this kind of data you have, so that you cannot perform with supervised learning in unsupervised learning, right? So for that kind of thing in which you have initial stage and goal stage only, right? So at that time you can perform a reinforcement learning, right? I have given this reinforcement learning as a chocolate learning thing, chocolate learning, right? So you are giving a chocolate to the machine. When that machine takes a good step or positive step towards the goal, right? As an example, if you want to uh, reach one place to another place, so right now I am here. I want to reach at the top of my finger, right? Top of my finger, right? I'm here right, right? And to reach that particular I lots of options, like I can long drive, take a hour, and ultimately again reach to that particular field, right? But my goal is to obvious goal is to reach that destination, source to destination is through shortest path, right? So this reinforcement algorithm is considering all the possibility, right? So from here to move uh, towards the goal, there are lots of options. So it will try all the options, nearest option, right? And at the end, what is happening? If that algorithm or machine will take a positive step towards the goal, positive step towards the goal, right? Positive step towards the goal. So at that time, machine will awarded with reward points, right? So same way, it will after reaching that reward point, it will try again and make some steps. And if that machine has some has taken some uh, long path towards the goal, right? At that time, we have to punish that particular step, right? So machine can understand by taking a reward and punishment, machine will construct a path automatically and ultimately reach to the goal. That is the method. So it is like chocolate giving and chocolate taking, right? Chocolate giving and taking, chocolate approach. Reward is approach. That is a postman, right? And if you look at the so human have capability to understand the pattern, but up to some dimension, as a human we can see this object, right? Or whatever available onto that particular object, right? But if we increase the dimension up to 4, right? This particular pattern is available into 2 dimensions, right? Crosses and circle available up to 2 dimensions, right? But what if we increase the dimension? If we add a third dimension, fourth dimension, fifth dimension, up to n dimension, so our eyes cannot have that much capability to infer pattern from multiple dimensions. Multiple dimension. Are you getting this thing? Multiple dimensions, right? So whatever the picture available onto 2D board, 2D space, that we can easily understand. And if we add one more dimension, 3 dimension, that also we can easily understand, right? But when we increase the dimension of data, right? At that time, uh, human have that human cannot identify the pattern available to the but the same thing understand easily understand the patterns available into the multiple dimensions. So this figure shows that thing, because machine machine has to follow some algorithm. If you provide a enough number of processing power, machine just have to follow the algorithm, same algorithm, right? So if you give 1 dimension, 2 dimension, 3 dimension, or n dimension, it has to perform the same task, right? But human has the limitation to identify the pattern from multiple times, but machine can do very easily, right? That's why for the pattern recognition task, nowadays machines are more capable than human pattern recognition task, right? Okay, so this is all about AI tree kind of thing, right?
Excuse
Now,
me, sir.
yes,
So,
Anish.
so there are a couple of questions that the participants have.
Yeah,
So, first is how can we collaborate machine learning and medical data? Is there
yeah,
any way to do that?
yeah. Of course. Nowadays, deep learning is one of the best way to collaborate with medical data into the that AI part, right? As I told you earlier, the classification problem, right? Radiologist, as an example, radiologist task is what basically a radiologist, let's say lung cancer classification or detection, right? So lung cancer, for the lung cancer classification, of the patient will analyze that particular thing or nodule. That nodule is a benign one or malignant. This is the official task of radiologist, right? Yes or no, Ansh?
Right, sir. Yeah,
Right.
yeah.
So same way, as I give you one method of left to right, top to bottom approach, CNN approach. So instead of radiologist, you can give the same CT scan to the CNN algorithm or CNN architecture. It will scan each and every pixel available into the CT scan and identify the different shapes and different structure available into the CT scan, right? And if you have already trained model with CT scan, it means supervised learning. It means supervised learning. So you have already given a lots of CT scans, lots number of CT scan to the CNN algorithm, and enough number of CT scan to the CNN algorithm. So now CNN have such a structure. So now how you can train this particular thing? If you will give uh, a CT scan with normal patient, CT scan of normal patient. That is normal patient in terms of benign nodule kind of thing. Instead of whole CT scan, let be some specific thing. You are giving a two different nodule category, the benign category and malignant category, right? So you will give a computer a region, ROI, region of interest, a region of benign nodule to the machine, to the CNN. Let's say 1 lakh benign nodule samples to the machine. Samples. And you will give 1 lakh more that CNN knows the structure, shape, shape of that particular benign. And yeah, there are lots more parameters to scan, but these are the general one. So the benign nodule have some structure, some strength, some weakness, uh, and same way the malignant having is some structural thing. I think most of the participants are from the medical field, so they know the HU, Hounsfield unit levels, right? So if you pass some malignant nodule to the CNN, the Hounsfield unit distribution is very different than the benign one, right? So these are the characteristics ultimately CNN can able to identify. So now, as I have given example of cat and dog, same way now my CNN algorithm is ready with benign and malignant nodule features. And when you give a new benign one or new ROI, region of interest, so it will identify, compare with benign and malignant, and ultimately it will produce this particular nodule, new nodule is look like a malignant one or look like a benign one, right? So this is how you can incorporate a vision. This is a field of computer vision, right? So image processing, through you can pass the image to the CNN module. CNN will learn all the feature. Apart from this vision section, or apart from this imaginary, you can add some history also. History of patient. Right. So have a excellent result. Some some way or some guidance to the disease detection part, right? So instead of scanning all the CT scans, right? It is very that patient one CT scan having a 300 to 400 slices. So he has to move that all slices. But instead of moving that all slices, what if that computer itself can draw a benign and malignant module, benign and malignant nodule onto the CT scan automatically, right? So that is why you can incorporate with these things.
Right? Great. Right.
Yeah.
There's one more question. Yeah. So why would we prefer unsupervised learning over supervised learning? Yeah, and like in what case is it of better use?
Yeah, of course. It is, as I told you, it is depending on data availability types. So in my cat, dog, horse example, if I collect that cat images, I can easily provide that cat images, cat label. So image with cat, or you can say C1 or C. The dog images you can provide D, so you can understand, or machine also can understand D is for dog. Right. So it is based on data availability. But what if you don't have a label for data? If you have signal data, ECG as an example, in your field, right? So you don't provide a label on that particular thing. So that particular data you can consider as a clustering way. Cluster in terms of you just want to identify a similar data. Same way you can apply with ROIs. What are the benign nodule available into the CT scan and malignant nodule? So what you can do, you can give that data to the machine learning through machine learning part, but that will scan all the features and try to make a cluster. Okay, like in our CT scan there is a bone also, right? So there is a nodule categories also, right? So that machine will able to identify different parts available into the CT scan, right? Without knowing the label, right? It will trained on characteristics. It will trained on characteristics, right? So now, are you getting what I'm trying to say?
Yes, sir. Yes, sir.
Yeah, benign and malignant, you are cancer classification part. If you have your CT scan with benign and malignant, so you can give to the machine. So machine will classify. But if you not providing that benign and nodule part, so what machine will do? Machine will take all the information from the CT scan, and it is having a different clusters. So this CT scan having a this CT scan having a 4 different characteristics. One is related to bone, one is related to air structure or nerve structure, whatever. I don't know about that particular thing. But whatever thing that the CT scan have, that distinguish two things, right? So that will consider as a one different cluster of the of that analysis. So cluster 1, cluster 2, cluster 3, cluster 4. So cluster 1 can be bone, cluster 2 can be, cluster 3 can be XYZ. You can cluster that particular, have a label part, so you can cluster that particular thing according to the characteristics. So there are unsupervised algorithm also, there are supervised algorithm also, right? CNN comes under the supervised learning. So CNN required data with label,
Right.
CNN required data with label. But unsupervised learning, you can consider RNN also a unsupervised learning, or there are lots more that that we can see in future if we plan the same.
Sure. So just one last one.
Yeah, sure.
During unsupervised learning of the machine, can it
Yeah.
malfunction and learn or get data that it isn't supposed to?
Yeah. Of course. That means what you are trying to say is uh, uh, whatever machine learning that malfunctioning, it means the disease kind of thing.
No. What I believe the person is saying here is that I don't know, maybe due to some error in the code or maybe in some way, if
Yeah.
if our algorithm is not correct or if something along those
Yeah.
lines,
Yeah.
then is it possible that
Yeah.
can
Of
get
course.
data that it isn't supposed
Yeah,
to?
that is the main threat of AI. Basically, you have heard that Amazon example also. You can search in Google if you want.
Right.
So yeah, so that is the main threat basically. So that if you, this is basically machine don't have sense, right? So whatever you are providing, it will take the help. But nowadays, because of that automatic feature learning, right? So machine can learn automatically. So if you uh, English language to the, it will try to run a Russian also, it will try to learn a French also, right? By
Right.
learning all these language, uh, artificial intelligence can also learn or invent a new language also.
Oh,
So
okay.
are you getting my point?
Yeah. I understand.
So what happens now? Now the thing is, whatever that robot is speaking, as a human we cannot understand, but two robots can understand. But two robots can understand that their language. So robots can talk without informing us, or this kind of thing is happening.
Okay.
So
Has
that
this
is
actually happened, or is this?
yeah, happened.
It's happened.
Actually
Okay.
happened.
Okay.
That's why
Thank
that
you, sir.
whole project is collapsed.
Okay.
But we can do something to control that particular part.
Right.
That is
Okay.
also in our hand. Right.
Thank you, sir. You can go on. You can continue.
Okay. So we have completed our whole, and one more thing, Ansh, I want to ask that our participants are getting involved, or just I'm delivering my lecture on in my way, or they are not getting something. Or
No, sir. They are asking questions at times,
yeah.
at intervals.
Okay.
Yes, sir.
Okay. So take their feedback also meanwhile.
Definitely, sir. Sure.
So we have completed that whole AI thing, right? AI tree. Now, if we look at the scenario, basically the problems available into the market, right? That is one problem is related to AI, and one problem is non-related. Non-AI problem and problem. What problem you can consider as an AI problem and what, right? So that's the thing. The basically when you have a problem that have specific structure or that normal non-AI AI algorithm has a uh, structure algorithmic problems, structure algorithm. So to solve a particular, as an example, uh, you want to add two numbers. That is your problem. So you want 10 plus 10 from the computer, right? So you have to follow a specific structure. You have to take first value, sum with another value, it will produce an answer. So these are the structured algorithmic way. So I have taken example of sum. You can take summation, multiplication, division, and number, mathematical operations, all the mathematical operations, right? So they have some specific structure. If you follow, you can have your answer. But in terms of AI, it is totally unstructured. It is totally unstructured, and it is very difficult to write a structured algorithm for that, right? Because it is a real-time problem, right? Real-time problem. It is having a real-time problem, right? So real-time, there is nothing is fixed. It is real-time is like fuzzy kind of thing, right? So you can't set a specific step for to solve a particular problem. So that kind of problems comes under the category of AI, right? Again, as I told you earlier, algorithm very easily. You can write 10 step, you will have your answer. But in the case of AI problem, it is having a probability. You cannot give the specific thing. You will have a probability. You can say that this will happen 10%, this will happen 50%, this will happen 80%. That kind of. You will have a lots of probabilities in each and every stage, like chess game you can consider, right? So you will have a lots of steps uh, or lots of possibility to take one step ahead, all right? So the possibilities are more, so you cannot structure that 1,000 steps and your answer, you cannot say that, right? You cannot uh, fit the concrete stage. You require some algorithm that can learn something by themselves, and then you can have your answer, right? So that is the AI problem. Then machine can solve the problem better than human. Non-AI problems, like all the calculation part, right? 1 lakh into 1 into 2, 1 lakh into 1 lakh 2,304, right? So machine will do that calculation very fast than human, because it is having a structured algorithmic approach, right? So it is into the non-AI problem. But uh, if we consider that AI problems, nowadays also humans are ahead than machine, right? Machine cannot perform a vision task more than human, right? Machine cannot have sense, machine cannot have feeling, right? So these are the gaps of AI. Right? Two types of problem, all right? AI related problems, right? So there are basically three domain related problems or three types of problem. One is a mundane task, second is formal task, and third is expert task, right? So expert task is related to the, you can consider as a medical field, as I have taken example of that cancer classification part, right? A medical diagnosis system, right? Um, um, IBM have already made that system also. If you remember that Watson, you can search Watson in Google, you can find that thing. Okay, so the three types of uh, problems, AI problem, right? So uh, the problems we are facing in our day-to-day life, or doing into the day-to-day life, that is natural language processing, speaking, listening, reading, writing, right? Problem related to vision, right? Perception, common sense reasoning, right? So these are, as a human, we are doing regularly, day by day, right? So that task is a problem of artificial intelligence, right? So artificial intelligence is working to solve that, right? Like NLP problem, like vision related problem, like common sense reasoning problem, right? So this you can consider as a day-to-day activity for human, right? Mundane task. And then second is formal task. Formal task in terms of game playing or mathematical right, and or these you can consider as a formal task that required more sense, or that required a lots of programming, in not a structured programming, but they required some unstructured kind of thing, because carom has lots of possibility, chess has also a lots of possibility, right? So we have to make such a structure that will incorporate some of the possibility, but that algorithm has such a capability that based on that probability they can infer a new probability and suggest a new answer or new decision, right? So that is a problem you can consider as into the umbrella of formal task. Okay, then the third is expert task. Expert task you can include like you can right now that particular task uh, is performed by some experts, as a human experts, like supervision into the examination, medical diagnosis, it means patient and doctor direct communication, right? The scientific analysis, research survey, right? Business analysis in terms of what you can say that uh, I want to start a new business. So, what kind of uh, um, customer I have to target? What kind of uh, uh, place I have to select by which I can get more profit on that? That is business analysis related thing. Perform with the experience performed by an expert, human expert. But the same thing. Actually, AI's goal. AI want the same task that has to be performed by computer, right? So they required a medical diagnosis system that can diagnose patients patients problem or disease without having a doctor consultation, right? So that is the interaction, direct interaction to the machine. Same way, scientific analysis. So we have to make such a structure. Normal scientific analysis is what we are identifying in your thesis or in your project, whatever you are doing. You identify the problem. You will make a such a survey. You will type that problem into Google, identify some of the resources, right, and make the hypothesis kind of things. Do some experiment, and then analysis of that particular, and finally you have some conclusion. So that is a basic scientific analysis done by us. So same thing, uh, computer, that same thing computer can perform by themselves, right? So that's the task. Nowadays there are lots of scientific analysis thing, like based on your paper abstract you can find your related journals to publish, right? That kind of thing. Business analysis also you can find lots of things, lots of ready-made software you can find to for the business analysis. One more thing is automatic self-driving car, right? So that is also expert task. Right now we are driving our car our, by our own, right? But that Nvidia has their own car, automated car BB8, right? And there are lots of other companies that are having your Tesla having it, that thing, right? And here is applications of AI. The application that AI has to focus is like predicting future, like weather forecasting, right? Then match result, stock market analysis, right? Stock price analysis, right? Stock price forecasting, right? So that's the application you can consider into the AI field, artificial intelligence, right? The third part, the second is your chatbot. Chatbot, you must remember that this thing, right? Chatbot in terms of instead of if you want to instead of mm, human chat, you will have a human robot chatting. You can find these chatbots in many of the tourism website or many of the education website also, right? So um, so in that particular thing, uh, AI is useful to generate that particular based on NLP part. All right. So the query of human are solved by robots, chatbots, right? So another thing is the self-driving car is one of the application of AI. Then AI doctor, yes, it is related to your field, medical field. AI doctor. So with the help of AI, with the use of that computer vision that can identify a diabetic retinopathy problem available into the eye, right? So that is called as an AI doctor, right? Diabetic retinopathy. I think you know this term, right? And diabetic retinopathy.
Yes, sir. I've heard of it.
Yeah. So instead of that eye surgeon, that machine will scan your eyes and say that and give you the probability of that if the patient having a diabetic retinopathy or not, right? So that's one more application into the medical field. One more application is AI music composer, right? So instead of human, now robot will compose a new music, right? Robot will compose a new music, right? So innovation into the field of entertainment, right? And last but not into the list, and my favorite one, that is AI dream machine. Through the AI concept, we can analyze our dream also, right? So what we are thinking in our dream, we can reveal, right? It is very sometimes, though it is a very innovative one, but it is very dangerous for us. It will reveal our all fantasies, right? So, but AI can do this, right? By taking the signal strength, by reading the signal strength at night. Ultimately, we are measuring the and that machine will measure the strength of that, and based on the strength they are generating and we can have some in sleep, right? He or she in sleep, right? So this is how. But this dream machine is not much accurate. Only 30% accuracy we got by this particular machine. So don't worry.
Excuse me, sir.
Yeah.
So there is one more question here.
Yes, please.
Just a minute. Right. How can we use machine learning to analyze biomedical signals like ECG?
Yeah, of course. So for ECG reading, that CNN, I already told you that CNN is basically useful for analyzing of image data, CT scan, MRI, that all you can give to the CNN. But this ECG, like signal processing kind of thing, it is a time series data kind of, right?
Yes, sir. Yes, sir.
Right. So for that you can use that remembrance part, because it is connected with its past time and future, related to future time also, right? So you can use RNN for that, recurrent neural network. So you can give that data to the RNN part. There are lots of architecture available, but that will take that will take more time to get
Okay,
into.
sir. Okay. So
Yeah,
just
but yes, you can directly give your ECG data to the RNN. If you have that signal in thing, right? But if you produce that ECG into image, so CNN for you, that stripped ECG script, if you give to the directly to the but you are taking that photo and give that particular thing to the that time CNN will run. Image related data CNN. Have I solved your question? Hello?
yes, sir. Yes, sir. Yes, sir.
Anything
Hello.
else?
Yes, sir.
Yes.
Sorry to interrupt in between, but I'll just have to inform you that we'll have to speed up this first session because we have a second session ahead of us.
Yeah,
So
of course.
just needed to inform you that. Okay.
Yeah, okay. It will take 5 minutes. 5
Yeah,
minutes.
sure, sure.
Okay. So let me move. These are the applications. Machine learning, right? Now we are on to the machine learning part. So machine learning, as the name suggests, learning into it, right? Learning. So learning is what basically learning we can define through this definition. Learn how machine can learn basically. So as I told you, machine can take a picture, read some features, analyze some features, and produce a feature map. And when you give a new image, it will produce a classification task or clustering task or whatever, right? So that is basically learning. So the steps of learning is what? Learn to assign an object or example. Object in terms of you can say cat image, or example you can same object and example are the same. So cat, dog, and horse image you can get to one of the several pre-specified categories. One of the several pre-specified category. Now, this is about supervised learning, right? So learning is what basically, you have to develop such a system that will classify cat, dog, and horse. You have to develop a system, AI system dog and horse picture. This for you is cat, dog, and horse. Cat, dog, and horse is your pre-specified category, and objects are the images of cat, dog, and horse. Yes, learning. How computer will learn, right? So learn to assign object. So we have to give machine to object, and that machine will learn that object and try to classify amongst the cat, dog, and horse. Cat, dog, and horse. So this is a basically learning thing. Let this is also known as a pattern recognition part, ultimately, right? So learning part, machine learning, how machine learns basically. So as an example, this is a one picture in front of you, right? So now I want to identify uh, um, what is into the picture, right? Is there any shape, any face shape, any teacup shape, right? Or any other category? Let me define my category also. So this particular picture, I have to identify that it is this picture is related to teacup, related to face, or related to phone. Related to teacup, related to face, related to phone, right? So now it's a machine task. So machine will take this picture, identify the features, right? So before that, we must have to understand, we must have to give lots of face images to the machine. So as of now, you just think that machine has already seen lots of images, teacup images, lots of phone images of that particular thing. Now we are giving this picture, this face picture. So machine has to identify this particular picture lies into which category, right? It is lies into teacup, face, or phone. So after analysis, machine will ultimately classify this given picture is lies into the face category. So this is learning. This is learning, right? Same way, these are the some of the example. So face detection, um, you can see in your Facebook account also, face tagging, right? Photo tagging option is there, that Facebook is already identifying your face and even notify you, this is your friend Mahesh, this is your Naresh, this is your friend Naresh, right? So face detection also and notification also, right? So that is already done by AI algorithm, all right? Face or not face, image patches, character recognition, right? So if you want to identify, if you see this picture, right? So when you give handwritten characters to the machine will able to answer this particular thing. When you pass 6, 8, 9, so it will identify the characters available into the picture, right? So that is based on CNN, convolution neural network. These also you can do by that face detection also you can do by CNN algorithm or CNN algorithm. Then medical diagnosis, right? Medical diagnosis. So you are giving medical image to the machine, and machine will every pixel, right? So there's kind of thing. And so as I told you, there are three different three different categories of machine learning, but you can also invent one more category, that is semi-supervised learning. That is mixture of supervised learning and unsupervised learning. That is semi-supervised learning. So sometimes you have label data, and for some application you have uh, label data available. For the same application, some instances have no label data, right? So how to tackle with that particular data? So that is a semi-supervised learning category, and reinforcement learning, right? So these are the then supervised. Through supervised learning, you can solve a regression task. Regression task in terms of as an example, it is a continuous data value, right? We will see this particular thing in next session for specific group of people, right? In general, supervised learning having a regression task or classification task. Unsupervised learning can perform a clustering and association task. Association is like finding a pattern kind of thing, related patterns, like bread and butter. Bread and butter is one pattern. That is the output of association rule algorithm, association mining rule. Bread and butter, right? So the output of this pattern is what nowadays you cannot find any shop that are selling bread but not butter, right? So it's a pattern. So one shipper in one is otherwise that customer has to go to other shop to buy butter, right? So that kind of thing. That is association. Semi-supervised classification and clustering combination, reinforcement, classification and control, self-driving car, right? So this is the categorization of machine learning, and this is the ultimate transformation of human brain to AI, human brain to artificial neural network, right? So you might know this. This is a typical neuron cell, structure of typical neuron in our brain, right? Which is having a dendrites that will work as an input. Nucleus is a central body, central part. Soma is a central body. Axon is your one kind of output that will take that will flow the input, and ultimately through the axon we will have some output signals, right? It will connect to some another dendrites, or it will produce some output also, right? So this is a typical neuron. So same way, if we want to mimic that particular thing, the central body called as a soma, so that in artificial neural network we can consider as a neuron. So these are the number of neuron. You can see these circles. You can see the circles. These are the number of neurons, right? Then dendrites work as an input. Here dendrites is that, so work as an input. So here x1, x2, x3 up to xn. These are the number of inputs, right? Axon is your output. So right, but how you can reach to the outs, right? A synapse strength, signal strength, right? So that we can consider as a weight here. right? So synapse and weights are there. So in biological terms, you will have a soma, dendrites, axon, and synapse. That is a basic functional element of brain. There are so these are the basic functional element of brain by which we are doing some whatever we are we are having in our intelligence part, or we are making some decisions, or so the basic elements are this four. So this four basic element we have to convert into uh, artificial network, right? So that artificial network you can generate by uh, making a neurons, taking some input output, taking input output, and weights, right? Okay, so finally this small neuron structure, the typical human brain neuron structure, we have converted into inputs, number of weights, some processing element. So while this dendrites take some inputs, that in nucleus there is some operations, right? Signal gathering operations are there. So that operation we have to perform. So here mathematically we are mm, right? As an example, to perform any task, like I want to wave my hand, right? So for that, there are lots of signals are generated, right? So that signal you can consider as an input x1, x2, x3, x4 up to xn, and that signal have some specific strength, and that strength we have considered as a weight here, synapse value, synapse strength. So each and every input has some strength. So x1 has W1, X2 has W2, Xn has W1, right? So, and now it's a task of operation, right? So nucleus will perform some operation. So here, in artificial neural network, we are performing a summation operation. We are gathering all the signals, and we are gathering all the signal strength, signals input and signal strength. And if that particular submission is more than some threshold, so that transform into a action, right? Like for waving my hand, I have collected that in our brain, I have generated some signal. If that signal crosses some strength or threshold value, then and only then I can perform action like wave hand. If not, then it is just a thought, right? So there is no action conversion, right? So same way here, submission and activation function. Activation function is like thresholding. After summing, if that signal strength is crosses some threshold, then it will convert into the output. Otherwise, not, right? So this is a structure of artificial neural, the mimic of our brain, right? Mimic of our brain. Increase. This you are increasing this number of layers like this hidden units, right? You will increase 1 2 3 4 5 up to n unit, and so you are ultimately increasing the complexity, connections of neuron, all right? So that will leads to a new field called deep learning. That will leads to a deep learning, all right? So I think I have done from my side regarding the, yeah.
Uh,
Yeah.
Thank you, sir. That was a very insightful session, and I hope the participants have also enjoyed it.
Yeah.
So, there are a few questions, but
Yeah.
since we have a time delay, I'll just go on to one of the questions which the participant has asked.
Yeah.
So, the question he asked was that AI is meant to use results from a study for medical studies and then extrapolate the results and apply to get the solutions. But what if the study is proven wrong? Okay, if the study is proven wrong, then all the results which were based upon that study would also be proven wrong. So,
Yeah. Yeah. Of course. So
can
study
AI
is
help in such a thing?
uh, no. Basically, that AI is what actually nowadays AI is turned into a data-driven thing. So whatever you will provide to the machine, whatever the data can be wrong data or right data. If you provide wrong data, machine will produce a wrong output. If you provide a right data, so machine will learn wrong data also. Machine will learn wrong data also, but it will not giving a higher impact for decision making kind of, right? So whatever data you are giving, that is very important.
Right.
Obviously we learn something instant, right? So data must be proven before applying into the machine. That
Okay.
is the thing.
So, sir, if an unproven data is applied and those results are, applied on the humans, and if something goes wrong, so who would be responsible? Will the person who had given the data to the machine be responsible because he was unaware of it, or will the machine will be responsible because he could not interpret the correct results?
No, for this particular thing, it is a debatable part, because it is varies from person to person actually. If that AI technology, that some higher level person has applied this AI technology, and so that higher person will blame on AI. But in normal regular situation, we will blame on human itself, right? So
Right,
it is debatable part. Right.
right,
So,
right.
but we cannot find a machine fault. We cannot find a machine. Whatever we are giving to machine will react based on that only, right? So it is our task to tune proper, proper, right? If something goes wrong, it's our fault basically.
Right, right,
The analyzer fault.
right. So, all right. So now we have ended with the sessions. So we'll just conclude this session, and then we can move forward with the next session.
Right. So, on behalf of the World Youth Heart Federation, I take this opportunity to extend a heartfelt thank you to Mr. Mrudang Pandya for conducting such an enlightening session on the topics of artificial intelligence like machine learning, deep learning, artificial neural networks, convolution neural networks, recurrent neural networks, and computer vision, to name a few, which are some of the most up and coming fields today. I feel that I can speak for everyone when I say that the way in which you explain such complex subjects in such a simple manner through some real life examples and comparisons with humans, of course, was truly amazing. I hope this session was informative for all the participants and gave you all an exposure to various fast developing fields of information technology and piqued your interest so that you can explore these fields more on your own. Well, just a reminder to all the participants, I would urge all of you to fill the post-event form that has been shared on your WhatsApp group as soon as possible, as you will be getting your certificates only after we receive your responses. Okay. I repeat, please fill the post-event form to get your certificates. Also, those who have received the Zoom link for the second session, kindly join the same